Especially Makini Karahan. Makina capacity another.
ඔව් ඇහෙනවා.
Alright. Okay. Now I'm going to start this session and I'm going to be doing this in the English medium because most of people are requested to do in English medium. Then as I can, I will deliver this with English medium. First thing I have to say, most of people are afraid about this EV exam and don't afraid that because only 20 spot test hostage will be asked from you, right? That they showing that hostage by using multimedia, and if you have a touch, very simple touch about some areas, right? Actually, you can give the answers for those questions, right? And from today onwards, we will help you to revise these principles and some theory areas, right, related to the hematology, right? And today onwards, I guess that next EB exam will be on 12th, right? Then until that, then 16th also another group will be faced to the exam. Then I hope to continue this until that, right, as I can, right? And others also will do something about this according to the other disciplines, right? Therefore, first thing is you don't afraid about the EB exam because especially when I talk about this Viva, right, they will ask the questions, very simple questions related with your section, right? First they will ask where do you uh, in your words like that, then they will recognize you and they will ask some small, simple questions, right? Simple questions from the area, right? Especially when you handling the specimens and what are the care and maintenance you have to take in your laboratory. Then some theory materials also they are asking, right? Don't worry, we can give the more information about the theory materials, right? Therefore, first thing is don't worry. බය වෙන්න යන්න එපා exam එකට. ඒගොල්ලෝ මේ Viva එකේදී අහන්නේ තමන් වැඩ කරන section එකට අදාළ දේවල්. Right? එතකොට simple theory, right? With simple theories, right? And OSP එකේ තමයි අර ටිකක් මේවා දාලා pictures දාලා ඉවරලා ටික ටික කොටස් විදිහට questions අහලා තියෙන්නේ. ඒකට we need some uh, more information, right, related with some areas, right? Therefore, first thing we will try to give a very good support to you, right? Each and every day until this, each and every day means as we can, right? Basically, will coordinate that. I also I hope to give the support to all of you. Don't worry, and I prefer you to participate to all these Zoom meetings. That will be very helpful to you because continuously we will not discussing these things again and again. Therefore, that's better to participate. And if you have any questions, you can put those questions into the chat box. I can give the answers as I know, right? Then we can start, right? Then today, actually, there were some questions, right, related with the hematology, right, related with the reticulocytes, and there was a question related with the full blood count report, right, and blood picture, no, full blood count report given, right. Then they ask some questions, right, related with those. Today I'm going to start with this few blood pictures, and now I'm going to share the screen, right. We will go with that. Actually, this is very suddenly I made this presentation, and if any okay. I hope you can see this, right? Patient screen එක පේනව නේද?
ඔව් සර් පේනවා.
Right. Okay, I hope all of you can see this screen. Now I am going to start some theory related areas and some routine investigations and related theories about those investigations and some areas that they can ask the questions to the Viva as well as the OSPI, right? Okay, first we will discuss about the ESR. Right. Now, what is the meaning of ESR? ESR is, it means ESR means erythrocyte sedimentation rate. Erythrocyte sedimentation rate. Okay. Now they can ask, they can give a picture of Westergaard tube. The tube that we use to do the ESR test is Westergaard tube. They can give a picture of Westergaard tube and they can ask some questions related with the ESR investigation. Right? Erythrocyte sedimentation rate. ESR, pathologically, ESR may high in the patients with suffering with some diseases. There are some examples I will, when I discuss about the some malignancies. Examples are multiple myeloma, right? Lymphoma, mainly multiple myeloma, lymphoma patients, they shows high ESR that is about more than 100 millimeters in 1 hour, right? Then other than the malignancies, ESR may be high in acute rheumatoid arthritis and pregnancy and tuberculosis or TB infections. ESR may high more than 100 millimeter, right? Then they can ask what is the principle of ESR, that can ask in the Viva, right? Then you must know this, actually this ESR mean erythrocyte sedimentation rate. No? Then according to the density of the red cell and because of the gravity, this red cell should deposit in the bottom of the ESR tube. But usually we know in normal healthy people, right, these red cell won't deposit in the bottom, right? That is why we can report about 5 millimeter, 10 millimeter in normal healthy people, healthy person. What is the reason of that? Usually you must know the red cell membrane charge is negatively charged. Then you know that theory, same charges have repulsive forces. Therefore, because of these same charges that present in the red cell membrane, these red cells are repulsive or repulsion forces we can see between these red cells, right? Therefore, in healthy people, this red cell, even the red cell have a mass, that red cell won't deposit in the bottom of the ESR tube. Actually, it won't go to the bottom of the ESR, even even though that red cell having a mass, because of these repulsive forces. But what will happen when the patient is suffering with some disease? Especially what happens, high ESR people, their blood will get more protein, right? Their blood will get more protein. As a result of that increased protein level, what happens? These red cell membrane cover with the proteins. Then what happens? This negative charge will be neutralized because of this increased protein level. Then because of the reduction of these repulsive forces in between these red blood cells, now that red blood cell will get deposit or will get draw into the bottom of the Westergaard tube, right? Then that happens actually. That happens in the ESR mechanism, right? මේ red cell membrane membrane එක negatively charged. එතකොට negatively charged red cell membrane එකේ red cell අතර තියෙන repulsive forces. ඒක නිසා තමයි healthy අයගේ red cell එක පහළට deposit වෙන්නේ නැත්තේ. right? එතකොට ESR high වෙන අයගේ, ඒ කියන්නේ pathological diseases තියෙන අයගේ මොකද වෙන්නේ, protein level එක වැඩි blood වල. protein වලින් red cell එක cover වෙනවා. cover වුණාම negative charge එක neutralize වෙනවා. එතකොට red cell එකේ බර නිසා මොකද්ද වෙන්නේ? මේ red cells deposit වෙන්න පටන් ගන්නවා. එහෙම නැත්නම් ගමන් කරන්න පටන් ගන්නවා වෙස්ටර්න් tube එකේ පහළට. That is what we read after the 1 hour, right? Now you can see this slide. Plasma protein, especially fibrinogen, adhere to the RBC membrane and neutralizes the surface negative charges, promoting cell adherence and rule X formation. Then you must know what is the difference between the rule X formation and red cell aggregations. Actually, rule X formation you can see in this picture. Rule X formation is a systematic arrangement of red cells like this, right? After one barack නිකන් මේ කාසි එක මත එක තිබ්බා වගේ තමයි rule X formation එක හැදෙන්නේ. That is the rule X formation. But red cell aggregation means clumping, red cell clumping. That is not rule formation. Actually, because of red cell clumping, ESR won't increase, right? ESR won't increase. Then red cell clumping can occur due to autoimmune diseases, right? Especially autoimmune diseases can cause red cell clumping. Not only that, due to the EDTA changes, that means prolonged storage of blood in EDTA also may cause red cell agglutinations. We call this as red cell agglutination. And another reason for red cell agglutination is cold autoimmune disease, warm autoimmune disease. However, because of the autoimmune antibodies, red cells may be aggregated, right? Because of actually that is not the reason for high ESR. Then that not leads the increase of ESR level. But rule X formation is this special systematic arrangement, right? Because of the rule X formation, that happened due to the rule X formation also occurs due to the increase of protein level. Then because of the rule X formation, your ESR directly increase, right? Then that says ESR is direct proportional to the rate of the cell or red cell aggregate and indirect proportional to the surface area, right? What I need to say is because of the rule X formation, your ESR level will be high due to the increase of the serum protein level in the blood or plasma protein level in the blood, right? Now, again, I will tell some pathological conditions. What are the pathological conditions? Multiple myeloma is one disease that can increase the ESR level, and lymphoma, that's another blood cancer that can cause high ESR, that can lead to increase the ESR level. And the diseases other than the malignancies, what are they? TB, tuberculosis. Another one is pregnancy. In the pregnancy, your ESR level may be increased. Then arthritis, right? Arthritis. Then rheumatoid arthritis also leads the increase of ESR level, right? Okay. Now I will discuss about the what is the test? What are the tubes that we can use in ESR, right? Then name of ESR tube is usually be using that Westergen tube, right? That can contain about 2 milliliter, actually 2 milliliter of blood, right? Then Westergen tube is usually routinely we use in our laboratories, and we can use another tube that that's somewhat similar to the half length of the Westergen tube, that is one enclosed tube, that is called Winthrop tube. Especially we use this Winthrop tube to do the packed cell volume, macro PCV or macro hematocrit, right? To perform the macro hematocrit, we can use this Winthrop tube, but except of that, we can use Winthrop tube to do the ESR. But in routine practice, we not use this Winthrop tube to do the ESR test. When they ask, tell another tube that we can use except of the Westergen tube, you can tell, that is, you can give the answer as Winthrop tube. You understood what I am telling? Then Winthrop tube, actually we have to fill this Winthrop tube by using a needle. Then you can hold this on a supporter or holder, like as we routinely do, like as we routinely perform the ESR test. You can place that Winthrop tube on that holder and you can read as usual, right? That is what we can do by using the Winthrop tube. Westergen tube also, that is the normal routine tube what we use in day-to-day laboratory wells, right? Then another thing I need to say, right? When you wash the ESR tube, what are the procedures? First thing is, once after you finish your test, you have to remove the ESR tube carefully from the holder. Then you can keep you can expose that ESR tube onto the running tap water, but that sink should be connected to the special drainage system. You have to tell because we are washing the blood. Then after that, you can put this ESR tube in general purpose detergent solution like soap water and keep for about 2 hours. Then you can wash thoroughly with running tap water again and tap water. That is better if you can use warm water for final washing, right? That is the correct procedure of washing of ESR tubes, right? YYKD ඔන්න ඔය වගේ ප්‍රශ්න අහනවා ESR tube ESR test එකට අදාළව ඒ related වෙන ඒවා තව ටිකක් අහනවා. ඊට අමතරව OSPI එකේදී tube එක දීලා ඔන්න ඔය විදිහට අහන්න පුළුවන් what are the washing steps දෙකක් විතර කියන්න කියයි. What are the types of tubes you can use to do this test like that? They can ask the questions, right? Okay. Oh.
ඉස්සරෝ මේ එතකොට high risk sample එකක් අපි handle කරනවා කියන්නේ ESR එකක් එතකොට ඒකේ washing steps කොහොමද අපි කියන්න ඕනේ?
ඔව්. high risk sample එකක්
Hello?
ඔව්. high risk sample එකක් කියන්නේ ඇත්තටම අපි high risk sample විදිහට තමයි blood හැම එකක්ම ESR වලට හැම එකක්ම අපි handle කරන්නේ high risk විදිහට තමයි. ඒක නිසා තමයි අපේ මේ special wash කරනකොට blood ටික අපිට special washing drainage system එකක් නැත්නම් අපි blood ටික අයින් කරන්න ඕනි 1% hypochlorite contain එකකට. blood ටික අයින් කරලා තමයි අපි ඊට පස්සේ ESR tube එක ආයේ running tap water වලින් wash කරන්නේ. right? blood ටික අයින් කරන්න ඕනි 1% hypochlorite තියෙන contain එකකට. එහෙම නැත්නම් අපිට directly wash කරන්න පුළුවන් special drainage system එකක් තියෙනවා. එතකොට ස්පෙෂලි අපි high risk sample එකක් විදිහටම තමයි ESR එක handle කරන්න ඕනේ. ඕනම blood test එකක් we have to consider it as a high risk sample. Now here you can see that Westergaard tubes. Now they can ask what are the factors that affect on this reading. They can ask, right? Then what are the factors that affect on reading? Especially if the sample is hemolyzed, that is affect to the ESR reading. Actually, that will make some difficulties in reading. That may give some falsely low results because of the hemolysis, right? Therefore, if your sample is hemolyzed, actually you should not perform the test. You have to repeat the test, right? Another thing is when your ESR procedure bench exposed to the sunlight, that can also lead to hemolysis. Therefore, you have to do the ESR test in a separate area that is free of that should be free of vibrations, that should be away from the sunlight, and that should be a well leveled, that means well elevated. So that means that should be good level, in a good level. That means level should be අර level එක හරියට තියෙනවනේ ඒක නිකන් අර angles තියෙන්න බෑ. That should be a perpendicular නේ. That should be a good level. Level එක හරියට තියෙනවා කියලා කියනවා, right? Then vibration free, then sunlight, away from the sunlight. Okay, those are the main factors that we have to consider when we doing the ESR test, right? Now these are the Westergaard tubes, and they can ask sometime, are there any other method to do the ESR quickly, right? You don't give the answer that we can do. Some people may know there is a method that short method we already heard, no? That is we can do the ESR test by 7.5 minutes. Then you don't go to say you don't tell it, right? Only thing is 1 hour ESR we must do, and other thing is that also recommended, but still that is not in practice, right? Therefore, better to tell that 1 hour ESR is the most preferred method, and according to the request, some clinicians they request us to do the 2 hour ESR. Then that also we can report according to the request, right? Then those are the things we should know related to the ESR. Okay. Now today actually in this OSPI they already gave some blood pictures. Previous they gave showed CML blood picture, and again, as I remember, some people say that they gave that iron, no, thalassemia blood picture, no? Right. However, now this is a blood picture that can give in your OSPE, right? Now you can see, I will explain, last day also I explained this morphology. I hope you can see my cursor point now. Now here you can see red blood cells and some different colors of the red blood cells. Actually, I will show normal red. Now here, this is a normal red blood cell. This is a normal red blood cell, and you can see hemoglobin content is more. Hemoglobin content is normal in this red blood cell, but in some red blood cells, you can see some more central pallor. More central pallor means hemoglobin is not there. Hemoglobin is very less amount that actually concentrated to the peripheral area of the red blood cell. Here, you can see that as a ring actually. Here, again you can see a ring type red blood cell. Hemoglobin content is very low. Then when we go through this smear, a major population of this smear is having that type of morphology. That means ring type red blood cells. These red blood cells we called as hypochromic red cells. Hypochromic red cells. Hypochromic red cells. And you can see some small shaped red cells here. Small size red cells, right? Those are called as microcytes. Microcytes, because microcyte is normally small in size. Then how we consider, how we talk about this size actually when we compare with the mean cell volume, that is less than the normal level. What is the mean cell volume normal level? 80 femtoliter to 100 femtoliter. Femtoliter is the unit of the mean cell volume, right? The normal range is 80 to 100. Actually, there was a question today, right? They gave a full blood count report with RBC number low, right? Then hemoglobin is somewhat 7.5 or something, right? Then MCV is 145, right? MCV is 145. MCH is again low, MCHC low, right? Then another thing is RDW. That also related with this blood smear. That's why I am telling this, right? RDW is high. What is the meaning of RDW? Red cell distribution width. Red cell distribution width. RDW means red cell distribution width. Red cell distribution is high there. RDW is high. That means if you having different shaped cells, different size red cells, okay, then the red cell distribution according to the mean cell volume is somewhat wider. That is why we call it as red cell distribution width. Red cell distribution width means from the mean cell volume, how amount that the remaining red cells volumes are deviating. That is the red cell distribution width. If your red cell distribution width is more mean, you have different shape, different size red cells. You understood that? Right. Now, according to this smear, you can see different size cells are there, right? Microcytes are there. Again, you can see there is another red cell, somewhat oval shape or elongated cell here, elongated cell. Actually, we call this as a pencil cell, right? Pencil shaped cell here. You can see that pencil cell, right? And you have microcytes, and you have hyperchromic cells and normal size cells also there, right? Then if you see this type of blood picture, you can say hyperchromic microcytic cells present and pencil cells present here. You can see pencil cells present. Except of that, now what this now here you can see this my cursor point, and this is another type of cell. Inside the red cell, you have a point, right? Hemoglobin point. This is the cell we called as target cell. This one is a target cell. Another target cell you can see here, target cell, right? Then this is a blood picture with hyperchromic microcytic cells with pencil cells, and occasional or few target cells are present. This is what is the pathological condition is iron deficiency anemia. This can give in next hospital because it won't still up to this level it didn't ask, right? Now this iron deficiency anemia blood picture. This is the enlarged picture of the same picture actually. Here you can see this is the pencil cell, right? And what do you think about this cell? This This is a lymphocyte. This is a lymphocyte, right? Don't worry about that. Actually, here this blood picture is related with the iron deficiency anemia. Then they can give this blood picture and they can ask what is the pathological, what is the clinical condition here. Then clinical condition is iron deficiency. This may be iron deficiency anemia, right? Then they can ask the questions. What are the other tests you can do to confirm this disease? Then you have to tell after the blood picture, right? You can do serum iron studies, right? Total iron, serum iron, then total iron binding capacity, transferrin level, transferrin saturation level, right? Those are the iron studies. You can do the iron studies, right? If you don't see any pencil cells in this blood picture, we don't sure that may be iron deficiency anemia, or the same blood picture can see in the thalassemia minor. Thalassemia minor disease. That is not a disease. That is not the disease. That is the carrier stage, right? Thalassemia minor. In thalassemia minor also, patients suffering with that thalassemia minor, also the blood picture you can see like this actually, without pencil cells. Therefore, if you see this type of blood picture without pencil cells, your answer should be, right? This may be iron deficiency anemia or thalassemia minor, right? Then how you differentiate it? You have to do these iron studies, and parallelly you should do hemoglobin electrophoresis, right? Hemoglobin electrophoresis to differentiate thalassemia minor. Okay, hemoglobin electrophoresis, or you can do HPLC, high performance liquid chromatography, to find out the types of hemoglobin. The thalassemia is coming under the hemoglobinopathies. Hemoglobinopathies mean, like the word is hemoglobinopathy. No? Hemoglobinopathy is having different abnormal hemoglobins, right? Therefore, thalassemia minor also goes to the hemoglobinopathies, right? What I need to say is, right, if you seen this type of blood picture without pencil cells, you tell that maybe iron deficiency anemia or thalassemia minor. To differentiate that, you have to do iron profile or iron studies, and parallel you have to do hemoglobin electrophoresis and HPLC, high performance liquid chromatography. HPLC means that. Then you can differentiate if that is thalassemia minor. You can find out by using those investigations. Then, if that is thalassemia minor, your iron studies will give the normal results, and hemoglobin electrophoresis or HPLC, that will give the thalassemia minor diagnosis, right? Then actually you can do pearl iron staining for to the bone marrow smear to find out the iron deficiency. That is not the routine practice actually. Normally bone marrow iron staining not doing we are not using in diagnosing iron deficiency anemia. But when patient suffering with the malignancies or hematological malignancies, sometimes when the patient is anemic, they do bone marrow, and they request the iron bone marrow iron staining. Then I will tell something about the iron staining. They can give the picture of iron staining. Then iron staining picture, if you observe iron staining picture, you can see some blue dots, blue aggregations in the bone marrow smear, right? Sky blue, or sorry, blue pearl color. That means blue color aggregations or blue color deposits on the bone marrow smear, right? They will give hints to identify that. No? This is iron stain, or this is a bone marrow staining from iron deficiency anemia patient or suffering with iron deficiency. Like that, they will give a hint. Then they will give the slide. Then you should identify blue deposits are there. Blue deposits are there. That is iron deposits in the bone marrow. Then to do the bone marrow iron staining, you need potassium ferrocyanide. Potassium ferrocyanide is the main chemical that you use to do the iron staining, right? Then you have to observe the iron deposits under the microscope after the staining, right? Then that is about the iron staining. I will discuss further, right? Okay. This is about the iron deficiency anemia blood picture, right? Okay. Now what are these? Now when you observe these cells clearly, actually these are different types of lymphocytes, right? These are different types of lymphocytes. Don't mislead with these inner pale areas. Those are not the nucleoli, or these cells are not the blast or immature cells. These are reactive lymphocytes. Now you can see these are reactive lymphocytes with some projections of the cytoplasms in between the red cells here. Those are called as scalpings. Scalpings of the cytoplasm. These are reactive lymphocytes, right? You can see these reactive lymphocytes when you given a type of blood picture with these type of cells. These are reactive lymphocytes, right? You observe carefully. These are dark. Actually, the cytoplasm of this cell is dark blue color, and you have different types of projections in the cytoplasm called scalpings, right? Then these are reactive lymphocytes. These can appear especially in viral infections. Not only that, when the patient is suffering with the bacterial infections,